I think we can start. Semen Troshkin will tell us how he assembled the cluster under Patroni and did auto discovery through Consul. Please welcome our speaker. Good afternoon again. I will speak about how we made Patroni cluster for 1C. So how it all started. As Anton said, Postgres in 1C came to 1C world gradually, and now it is taking momentum. Postgres came to us as far as the database management system is concerned a bit later, so it started coming to us from that side. So on our side we tried to use different scripts, replicas. We did everything with our hands. We wrote scripts. Because we did all this, not for the main system, we had a lot of failures, we had a lot of issues. And when we came to the point when we had to choose a system, we had to transition to a system based on Postgres, we thought about fail-safe system that would ensure stability. So my report will be about that. A few words about myself. I work in a major international company, Mazaros. We do outsourcing of accounting services, audit services. We have a lot of renowned customers that we support, quite a few databases of different sizes, from very small ones to huge ones. We use Postgres, and we try to ensure that our services are stable and reliable. Here I will speak about a general picture, general arrangement. I will later provide details about it. So how is the cluster organized? At the lower level, we have Postgres, master and replica, followed by the managing system, Patroni, or the control system. Patroni stores all data in Consul, and Consul performs the DNS resolver role as well. And then we have 1C. So on application servers, we install DNS Consul client, and this is the way we ensure access and connection to our databases. Let me tell you what we had in the very beginning when we started working with Postgres, when we started developing the Postgres cluster. We had, well, 1C world uses a lot of hardware servers, not necessarily, but in many times, in many instances, and that was the case in our company. It is not easy to establish relationships with data centers to have your servers to ensure high productivity. So for the data center, we're not big enough. Yes, we're a big customer, but not very big. So nobody will provide too many racks for us in a data center. That's why we use hardware servers in our operations. Our main goal was because for Postgres, we need two servers, the master server and the replica server. So we had to use them at the highest capacity and to distribute the load across the servers. I will later tell you which arrangement we ended up with. Our objective also was to reduce the influence of the human factor. Our system had to be very simple, reliable. So when we have a new person in our team, we want him to understand the system quickly and easily. On our side, we were thinking about Pacemaker, Chorusine, Patroni, and out of those solutions, we liked Patroni most. It seemed the simplest, easy to use, and we had used it on some platforms before. And Patroni demonstrated very good performance. It is simple in terms of administration. I will also show you how it works, how it processes many failures in the cluster. So in our case, it is important. Our main objective is to address customers' issues, clients' issues. So this is why we eventually went for Patroni. I think I said already that Patroni is good, stable, easy to use. So it was a very good choice for us. This is our operational arrangement. So these are the servers. So this server is a virtual server placed on one of the application servers. So we have 3 application servers here, 2 servers for Patroni and Postgres. So how do they interact? We deployed Postgres. By the way, in the end, I will show you my GitHub where you could download Vagrant down and deploy the system, so you'll be able to play with it. So this is the accounting and the payroll services. So here we have the master of the accounting server, and here we have the replica of the accounting server. Same for the payroll server. Master server and replica server. This is how we distribute the load among those servers. Those servers are similar in configuration, in terms of speed. Both replicas are restored quickly. Failover, switchover is performed quickly. Our lag is very small, thanks to those resources. So in every instance, we deployed Patroni. Patroni automatically launches Postgres services, controls latency of the replica. So in our arrangement, we decided not to use HA proxy, virtual IP, VRP protocols. We thought the fewer the components in the cluster, the higher its stability and reliability, because Patroni stores everything in Consul. Here is what we have. The customers get connected through Consul DNS. There is the single point of access, which is Consul DNS. In the DNS server, we indicate master.pogbook.console, and at this address we can resolve this master for the accounting server. So we switch to this instance. So the accounting database switches to this instance, and Consul DNS resolves a different name and different IP address. And by doing this, we achieve stability of the system. If Consul Patroni fails, if Consul fails, Patroni stops the operation of the servers, processes all failure modes, so if there are big issues, the system shuts down in this case. But we do not have split brain, and the two masters do not have this. We reduced the number of components in the system to ensure stability. I will also tell you how this happens from console point of view, the single point of access, which issues we had and how we resolved them. Single point of access, which is console. On this slide, I listed some important items. How console is organized. If we make one step back, we will see that on the operational servers, on the working servers, on each instance, we have a console with a server role, to avoid split brain. How do we achieve the server availability? Console is also a cluster which makes selection, well, who is the master, and in a normal cluster there should be 3 components to achieve quorum and to ensure election. So one of the console server is placed on the application server. So if one node fails, we have 2 console servers, and they help us continue the operation. On 1C servers, we have DNS, console client, with a role. When the server addresses to us, it addresses not through IP of one of the console servers, it addresses the local host at 127.0.0.1 address. So the whole of console system ensures all interactions. So the console is responsible for all interactions. What issues did we have? We selected UMask DMS at console website. It offers different DNS servers for use. So we tested several of them. The most stable turned out to be Bint. We operate on Windows, and therefore console, the client, it publishes things on an appropriate port. To have DNS on port 53, an additional DNS server is required. So we have selected Bint because we had different types of problems. We also send queries for resolve. it resolves names, and if it stops resolving, which sometimes happens, on a rare occasion though. So when we tested different servers, Bint demonstrated the most stable operation. It is sending to IP config/DNS. It cleans up cache DNS, and everything begins to work. We do not have instances of that any longer, but we used to have them because of selection of other servers. What else can we say? Each DNS server has its record life cycle, time to live. By default, Consul makes TTL null.
So, thanks to this, we received the name at once, and it remained valid. What do we use in Patroni? Why is it so convenient for us? Well, actually it's very simple. We can manage it in the following way. Config files, list, poo. And on the servers we can have several config files. However, in this case, Patroni controls them by itself. So, in this situation, we can use any file. We can specify server name, like poo, soup, and here you can see the list of commands. So, list command shows us clusters, shows us the leaders, and on the whole, here we can see the lag of master from the replica. So this is the leader, and here there is no lag. Although the load in this system is quite high. Sometimes lags happen, but everything was selected in the appropriate way, so it works in a stable manner. Edit config, that is for editing Postgres configuration. It is stored in queued storage, and when we press edit config, the editor that was specified by default opens it, and we can edit Postgres configuration. After changing some parameters that can influence the server restarting, we can see another column that is pending restart. So it means that it's waiting to be restarted, and we can select the time. It can actually restart it automatically at night, and we can also do it manually. So we can specify restart command, and after some time, if we do it manually, not by scheduler, the cluster will be restarted. We also use reload. If configuration wasn't significantly changed, reload will reread the configuration. It could control it by itself, it could control master and slave. So it does it by itself, it's really convenient, and once the admin, if necessary, can change the configurations and use it. And if it's necessary to conduct some job in cluster, for example, or you want after auto failover not to take place, we can specify a pause. In that case, in the list, the maintenance mode will be turned on, and in that case we can see that the cluster is in the maintenance mode. It will not have auto failover. So To withdraw this maintenance mode, there is a special function here, so it will continue doing it. When we maintain a server, instead of list, we specify switch over here, and here we should write boop, zoop, and it will switch the nodes, and we will be able to stop the server, restart it, and install additional software. Reinit. In some cases, we need to reinitialize one node, and if you launch this reinit team on master, Patroni will not let you do that. It will say that you cannot do it on master. And really like it about it. It is very convenient. So in the past, when launching some scripts, it was possible that you accidentally launched a wrong script. As a result, some problems could occur, but Patroni helps us to avoid such problems. That's why we really like it. It's very convenient. And now, I'd like to say a few words about automatic administration. 1C world, well, and as I understand, today and yesterday you discussed it behind the scenes, and some companies use Ansible, Git, and we. Well, many 1C experts, so I attend InfoStart conference for 1C experts, and I have attended it since 2012, so I talked to various administrators during a series of conferences, and I realized that people underestimate this tool. They do not use it in their work, saying that if we had 100 servers, then we would have needed to use some systems such as Ansible, Puppet, and others. Well, we can imagine a case you have an administrator that had set the server, that had specified some parameters of the kernel, everything works, everything is fine. After that, this administrator leaves the company, and some time passes, you need to reinstall the server once again, and all this history of settings can be lost together with this person. And when a new person comes, they will have to resolve these problems once again until the necessary settings are reached. That's why in our work we use Ansible for deployment. However, we have few servers, so the system installation and disk setting is done manually. The reason is that we do not have many servers, so it is normal for us. And when we need to open a port, we can introduce several strings to open a port, and we press apply, so the server deploys it in a very fast manner. It's very convenient. So I think that some companies in 1C world use it, but, well, I think that it's really convenient. I am the head of the department, and for me, it's important. I understand that maybe someday I will leave the company and I will leave all the work in these scripts, all the work that I had done. All the scripts are idempotent. What does it mean? For example, production server is operating. We launch Ansible, and we need to open a port. I can launch playbook that will open the port, and and I won't need to do anything manually. I can do everything in the automated mode. So it is very convenient. And in the end of the slide, I will show you my GitHub. It is possible to deploy a cluster there and play with it. There are some people from 1C world that do not want to use Ansible. On the left, we can see the roles, and on the right, we can see the tasks. So here we can see the hosts that we use for launching. This is the host file. And regarding the roles, for example, OS role, we can see it here. I mean that any administrator with minimum administration skills can read this script. It is quite simple. So this is the role, and this is Consul. There is the role of Consul, and it builds a tree as well, and you can enter it and see the scripts. And actually, I published testing materials on GitHub that describe this example. Here you can see the tasks. Install package, for example, so you can see the packages that are installed. Firewall is on, so it is really convenient. And I call on you to use such things more frequently. 1C world is very closely associated with Windows. So, a virtual machine with Linux is installed on a Windows machine. We launch Ansible from Playbook, and we deploy our servers from there. That's why it is very convenient. This is my GitHub. We can download the image from this place. It can be done on Linux, or it can be done on Mac with Ansible installed. When we do Vagrant up, it deploys the machine, and after that, Ansible uses the scripts. And there are servicing scripts, the simplest ones. They can be used when you have several bases. But if you're an expert, you don't really need to check them because they're very primitive. So that's it for my presentation. Thank you. And this is my contact data. And I will be happy to talk to you about it during the break. And you can always come up to me if you have some feedback. If you want to criticize something, you can always come up to me. Colleagues, we have 5 minutes to ask several brief questions while the next presenter will be getting ready. He will speak about Patroni as well. So, if you have some questions, you can ask them. You can raise your hand and I will give you the mic. Hello. So, judging by Patroni KTL output, you use asynchronous replication. Why? Yes, we use this replication because for us, well, we're not a bank, and within several minutes is okay for us. So, synchronous replication is not within our business tasks. But on the whole, if we add a node, if we make one replica synchronous and the other one asynchronous one, it is also possible. Patroni works with it as well. And we do not use it in our work. For our business tasks, asynchronous replication is sufficient. And what version of Postgres do you use? Postgres Pro or Enterprise? We use a version for 1C. produced by 1C company. Very recently, we had a problem related to it. We are using the 11th version published on 1C website, and recently we had a problem when we needed to connect tables. An error occurred. DBMS wrote it down in the wrong area of memory, and the cluster was stopped. On the 28th or on the 29th of January, they issued another version that helped us resolve this problem. Indeed, we are faced with some problems because of the vendor sometimes. Thank you for your presentation. You said that you have various volumes of information in your database. So, you used it on a specific volume of information. So what is this volume approximately? Just for us to understand the volume, where it can be implemented and what the disadvantages are. Well, speaking about the sizes of our bases, about 200 bases account for several terabytes of data. And we have stable operation on this volume. Our servers are good as well. The question is, have you ever reached the volume when some deadlocks or some accidents happened? And what can be the consequences of that? In terms of 1C, all deadlocks, and I am an expert on technological issues of 1C, and we have a technological log that we monitor. We had some problems related to the parallel nature of our work, so we had to rewrite the queries. We monitor this situation. So 1C has its own approach and recommendations regarding the way it should be done and settled. So we use all of that. Sometimes we're faced with such issues and we can resolve them. And we have various bases for processing. The outcomes are calculated there, and we have all these range. Anton can tell you a lot about these issues. So in my presentation, I decided to focus on the cluster to explain you why we selected it and how we did it. Thank you for your questions. Let's thank the speaker.